All right, let's take a couple of minutes to take a look at this protein folding exercise. This is a screenshot of what you get when you access the website. You can see it's a long chain of amino acids. Excuse me, some of which are green, some of which are gold. That means something in terms of their properties. Parts A and B are pretty exploratory. Let's take a quick look at the assignment. Part A is that you're supposed to play around with the controls and record interesting features and observations. So you can see there are a number of buttons down here, and really choosing any one of those and being alert to what happens when you choose that would be helpful. So don't fill in anything in this first column here. It's just a list 1 through 7. But right in here, you could tell, what choice you made and kind of what happened when you made that choice. Let's do a little example. So let's say you decided to make a random protein. You can see that the sequence changed. What about all hydrophobic? There's a pretty obvious change there. So you've got a lot of choices to make. I won't go through the whole thing, but you've got a lot of choices to make, and it's really important to explore. And as you explore, you'll put your choices that you made in this column here, and then what you noticed in that column there. So that's part A. Part B is this here. Okay, it's a directed task where you're going to categorize the 20 amino acids. And this works best with a team, but you'll be working solo. But there are some shortcuts. On the last page, there are 20 amino acids. You can find their names, and then you're going to put down whether they are charged, plus or minus, or perhaps neutral, and how they react to water. Are they hydrophobic, which means they are afraid of water or resist water or try to get away from water, or hydrophilic, which means that they are drawn to water. Here's a shortcut for kind of getting a lot of that information all at once. Go ahead and click on a protein. We'll pick on this big one, the phenylalanine. Oops, I need to run the simulation. Okay, so I'm going to pause it, and I'm going to click on phenylalanine. Oh, hang on a second. All right, let's try that again. I'm going to click on the phenylalanine, and you see that it comes up in the list of hydrophobic phenylalanine. So there's the name. But you also have all of these other names, glycine through tyrosine, and they all have one property in common for sure, and that is that they're all hydrophobic. So you could take a couple of minutes, just write down the names and identify them as all being hydrophobic. You can also find the list of hydrophilic. I just clicked on that, right? I can open that for hydrophobic. Open that for hydrophilic. There are the hydrophilic ones, and you see the ones that are charged actually have a sign next to them. The ones that don't have a charge must be neutral. So that's a pretty simple way to kind of get your catalog done for part B. Once you finish A and B, you can go to task C, which is a little more challenging, requires a lot of thought, and is not something to be done quickly. You're going to be choosing 2 of these 3 questions to explore. And your job is to use the features that you discovered in parts A and B, and you're going to make a claim based on evidence and reasoning. That means that you're going to come up with an answer to those questions that is based on what you observe with choices you make with the simulation. You want to create a document. You want to be dropping screenshots of your work into the document and provide any sort of text to go along with that, to help your reader understand what it is that you're talking about. Let me show you an example here. So we have completely hydrophobic set of amino acids in water. And you see they're all clumping together trying to avoid the water. And the winners are the ones on the inside, if you will. But if we can change the environment to oil, which is obviously not water, and notice how the shape changes, it really opens up quite a bit. It's like a solvent, if you will. And you notice that there's still some, like there's a bond right there. There may be some folding that happens right in here for some reason. There may be some slight bonds that are happening. We'll see. But you have to just sort of watch it for a while. But clearly, the hydrophobic versus hydrophilic nature of the protein, of the amino acids, has a real impact on the shape of the protein. Okay? I want to suggest the most interesting things to explore would be, say, mostly hydrophobic. Look at that. There are some hydrophilics in there, and that, while there's still a lot of spreading out, there's a little bit of contraction that happens there in the oil. And let's take a look at what happens when we put in water. There's a real difference that happens in here. Okay? So, your job is to explore, say, that first question about how hydrophobicity changes the shape of an amino acid. Okay? So you have to be clever and kind of make some choices here that'll allow you to sort of highlight your answer as best as possible. I'll tell you this, a random protein with sort of an equal mix of hydrophobic and hydrophilic, it's actually very difficult to see some big changes because the randomness of it means that the impact of the hydrophobic and the hydrophilic amino acids are about equal. It actually gets hard to see changes. So I'll let you struggle with that a little bit. That's an important piece to think about. Okay, last couple of comments. You're going to pick any two of these three questions and try to address them as best as possible. You create a document with your questions and your evidence and your reasoning and eventually the claims that you make. Okay? There's a rubric here, and I'll just highlight for you that top scores include thoughts about interactions between very specific amino acids. Okay? If you're looking for a top score, you're talking about the shape, but also about the properties of the amino acids that are making that shape the way it is. I've got a couple of other resources to share with you, one of which is, let me just change the screen a little bit here. Hang on one second. One resource that I'll give you once you complete A and B is this set of the amino acids along with their properties. See, up here it says amino acids with electrically charged side chains, positive and negative. Here are polar side chains, and then down below are hydrophobic side chains. So these all have different properties, and you should look carefully at this and try to make some strategic choices. You can also use your codon wheel to decide what kinds of changes you're going to make. If you've got a sequence, excuse me, if you've got a sequence like glycine and you want to make a change to something else, you might be able to use this codon wheel in some helpful way. Probably this page is going to be your best bet. Okay, so that's a brief overview. I'm happy to answer other questions, but I thought that might help get you started.